Yesterday about how we can't have radicals in the denominator. And what we were able to do yesterday when we were looking at the problems is the denominator was always a perfect square, or we could reduce the fraction and it kind of went away in the denominator. So that denominator wasn't a radical. Today what we're going to do is we're going to do what's called rationalizing the denominator. Rationalizing the denominator essentially means that we're going to make sure there's not a radical sign in the denominator, and we're going to show you how we do that without changing the value of the problem. Okay? So for example, if we have something like 2 radical 6 over 3 radical 24, if we go by what we did yesterday we talked about first thing you need to do is look for perfect squares underneath the radicals. That doesn't happen. Next thing you need to look at is, can you reduce the fraction that would be created if we rewrote it as the square root of 6 over 24? Well, yes, this can be reduced. So if we reduce this one, this 2 stays here. What goes into both 6 and 24? There's a bigger one. 6. 6 goes into itself how many times? Once. And how many times does it go into 24?
4.
Yay. 4. Oh, well, now we've got perfect squares sitting there. So square root of 1 is 1, so that's just 2. Square root of 4 is 2. 2 times 3 is 6, so then we can reduce that again to 1/3. Okay, so we use the rules that we talked about yesterday. There's nothing sitting there. We got rid of the radical that was in the denominator, that potential problem. Okay, well, if we look at this one, now we've got 6 over radical 3. There's no perfect squares in there that are underneath the radicals. There's no radical in the numerator, so there's nothing that we can reduce. So the question now is, how do we go about solving this problem so that we don't have a radical in the denominator and we don't change the value of it? Okay, if I have 1/2 and I do all this stuff and I still want the value to be the same, it still has to be a half at the end. Okay, so if I put this in a calculator, you're going to get a decimal. When I do the manipulating that we're going to do here in a second, that decimal that I started with has to be exactly the same. It can't change its value. So, if I want to not change the value of something, what operation can I use to not change the value but change it? If I add 0 to it, do I change its value? No, but is adding 0 going to do anything? No. If I multiply, what do I have to multiply by in order not to change its value? So if I just arbitrarily pick a number 3, and at the end, I have to multiply it by something, and I have to get to 3 again, what do I have to multiply it by? 1. Okay, so I have to multiply it by 1 in order to keep it the same. Okay, well, multiplying this by 1, I'm still going to have a radical in the denominator, right? Okay, so I can't multiply it by 1, but let's go back to this 3. Let's say that I go 3 times 4 over something. Can't change its value, but I'm going to go 3 times 4 over something equals 3. What does that 4, what has to go in the denominator of that? It has to go in the denominator of that. Because we just said that 3 times 1 is 3. So 3 times 4 over what is still 3? It's 4 over 4. So if I multiply this by 4 over 4, 4 over 4 is just 1, right? I haven't changed its value, but I've done something different. Okay, so let's now think about this one here. I have to get rid of the radical in the denominator, but I need to multiply it by something that's equivalent to 1. Anybody have any ideas? What could I multiply it by that would get rid of the radical in the denominator that is equivalent to 1? 6 over 6? 6 over 6 is equivalent to 1, right? Is that going to get rid of the radical, though? If I go 6 over 6, that's 36 over 6 radical 3. I haven't done anything. I haven't helped it. Any other ideas? What do we do when we multiply radicals together? So if I take, again, side note here, if I take radical 2 times radical 2, what's radical 2 times radical 2? Radical 4. Or what's the square root of 4? 2. If I take radical 6 times radical 6, what's radical 6 times radical 6 going to be? Radical 36. But what's radical 36? 6. If I take radical 3 times radical 3, that's radical 9, which is just, not radical 3, just 3. Okay, so now let's look back at this problem. Look at the examples I did. What could I multiply it by to get rid of that radical 3 in the denominator? Not just 3, radical 3. If I multiply both the numerator and the denominator by radical 3, that's equivalent to 1, right? So I'm still multiplying it by something that's equivalent to 1, just like 4 over 4 was 1. That's still 1. Okay, so I'm not changing its value. When I multiply the top times the top, outside by outside, inside by inside, radical 3 times radical 3 down there we just said was radical 9. So this goes to be 6 radical 3 over 3. Now I've got the 6 and the 3 are on the outside. So what goes into both 6 and 3? 3, good job. So our solution to this is 2 radical 3. So 2 radical 3, if you punch that in your calculator, 2 radical 3 is going to be the same thing as 6 over radical 3. They give you the same decimal. What it is, I have zero idea. But they give you the same decimal. So the way we get rid of the radical in the denominator, okay, so this is the key to when you're rationalizing denominators. You multiply both the numerator and the denominator by whatever the radical is in the denominator. And it just has to be the radical that's in the denominator, nothing else. Just the radical, as long as it's a single term. Okay, so let's look at another example. Maybe. Not that one yet. And these aren't going to show up. So let's go 5 over 2 radical 5. We've got a radical in the denominator. It's not a perfect square. So we need to rationalize it. In order to rationalize it, we are going to multiply both the numerator. Come on. We're going to multiply both the numerator and the denominator by the radical. And it only has to be the radical that's in the denominator. So we're going to multiply this by radical 5 over radical 5, which again is equivalent to 1. So multiplication, outside on outside, inside on inside. Outside is 2. 5 times 5 is 25. Okay, so now we've got that perfect square in the denominator. Square root of 25 we know at this point is just 5. Multiply that 5 and 2 together. So we've got 5 radical 5 over 10. 2 times 5 is 10. Now we've got a 5 and a 10 outside of the radical. 5 goes into itself once, so this 5 becomes a 1. This 10 becomes a 2, and you just drop the 1, and that's your solution. You multiply whatever it is, if you got a single term, by the radical over the radical. And then you simplify using the multiplication stuff that we used yesterday. Okay. Let's try another one that looks like that. Let's go 6 radical 2 over radical 7. So we've got 6 radical 2 over radical 7. We look for perfect squares for radicals. There aren't none. We look and see if we can reduce the fraction. We can't. Now we have to multiply it by. What do I multiply it by? What over what?
Radical 7 over radical 7.
Thank you. Radical 7 over radical 7. We multiply the top out. 6 radical 14. Radical 7 times radical 7 is radical 49. So that gives us 6 radical 14 over 7. That's your solution, and you're done. Okay. It's got to be that equivalent. Got to be that equivalent. Okay. Try one on your own. Let's go 2 plus radical 5 over, let's go radical 3. Simplify that, and a little warning, remember that's inside parentheses. So you will have to distribute the radical into both of those spots. Go, go, go. Girls cross country team won the meet last night. This is the trophy.
Wasn't the pie in it?
Inside of it, there was a pie in there, but it got destroyed. Okay, we ate it all. Isn't that a cool trophy? Isn't that much more fun than a trophy itself? A pie when you finish the race. It's the only trophies that I keep anymore. I used to keep the other ones, now I only keep pie boxes. The girls did a good job last night. It was fun. Guys did a good job too last night. We were 4th. Guys were 4th. What do I multiply by? Radical 3 over radical 3. So we got to remember to distribute. So that's 2 radical 3 plus radical 15 over, what's it going to be over? In the end, what's it going to be over? 3. Radical 9. Save yourself some writing. You know that's radical 9 at this point. Just put 3. That's your answer. Remember, these cannot be combined. What's underneath the radical is different, so they can't be combined. So if I have a single term, are we okay with rationalizing it? There's just a single term in the denominator. All right, the next step then is what happens if you have more than one term in the denominator. So now we have 2 minus radical 3 in the denominator. So now we have to deal with what's called a conjugate. So I can't just take this one and multiply by radical 3. And don't write this down. I can't just take and multiply this by radical 3 over radical 3. Because what would happen, and again, don't write this down, this would give us 3 radical 3 over, this is thought up as a grouping, I would have 2 radical 3 minus 9. Okay, again, I did that fast. I know, give you a couple seconds to process what I did. Okay, that's long enough. But notice what I still have in the denominator. I still have a radical in the denominator. So I can't just multiply it because there's 2 terms, 2 minus radical 3. I can't just do it that way. There are little gnats and flies. Are they buzzing anybody else? There's the fly. There's this huge fly that's been in here all morning. And then there's little gnats flying around this room too, bugging. Anyway, so we've got that. And so we haven't helped anything. So what we have to do is we have to multiply by what's called the conjugate. When we're multiplying by the conjugate, what happens is the number that you have, whether the number is first or second, the regular number you have, you leave that number the same. You don't change it. You just put 2. And it's going to go both in the numerator and the denominator. What the conjugate does is the conjugate changes the sign of your radical. The number stays the same. The sign of the radical changes. So it was minus the square root of 3. The conjugate of this is going to be 2 plus the square root of 3. So when we're talking about a conjugate, we're going to change the sign of the radical. Leave the number alone, but change the sign of the radical. So now, these are all thought of as groupings. So these become a little bit more difficult. Because now we have to distribute 3 times 2, and I hope you're writing now. I should have said you can write now. 3 times 2 is 6, plus 3 times radical 3, which is 3 radical 3. But now watch what happens on the bottom. If we FOIL on the bottom, 2 times 2 is 4. 2 times radical 3 is plus 2 radical 3. Now we go on the inside, we've got negative radical 3 times 2, which is negative 2 radical 3. So look what's happened to this middle part. That middle parts, they're now opposite of each other, and it's going to eliminate that radical. And then we go negative radical 3 times radical 3. That's negative radical 9. But what's the square root of 9? Square root of 9 is just 3, so that becomes minus 3. So that radical 9 isn't radical 9 anymore, it's just negative 3. These 2 middle terms give us 0 radical 3, so they essentially just go away. So we're left in the denominator with 4 minus 3. So our numerator here is 6 plus 3 radical 3. Our denominator in this case is just 1. It's not always going to be 1, just happened in this problem. But now we've got rid of that radical in the denominator. It's not down there anymore. And we did that by making a conjugate. And again, that conjugate, put it away. The conjugate is made by changing the sign of the radical when you have 2 terms in the denominator. Okay? So let's look at this example. So we've got radical 2 over 3 plus radical 5. So the first thing we want to determine is okay, what's our conjugate? What are we going to multiply it by? We leave the number alone. So it's going to go both in the numerator and the denominator. We change the sign of the radical. So instead of plus 5, it's going to be minus radical 5. So there's our conjugate, 3 minus radical 5. Okay, now I want you to go ahead and see if you can simplify that. Go ahead. Okay, so we do the numerator. That gives us 3 radical 2 minus radical 10. Denominator, I'm going to do it right here. 3 times 3 is 9. Plus, or minus, I guess it's probably minus. Minus 3 radical 5 plus 3 radical 5 minus radical 25. So the middle terms eliminate each other. This is going to leave me with 9 minus the square root of 25 is 5. 9 minus 5 is 4. And that's your solution. Now, some of you may be thinking, whoa, can I reduce this? This is 2, this is 4, and this is 10. No, you can't. This isn't underneath the radical, so you can't do that. Okay? You can only do that if you had numbers there, there, and there that you could reduce. Okay? Questions with that one? All right, don't write that one down. We're not going to do that type in here. So let's go with 2 over 5 plus, next week I work on my penmanship, 2 over 5 plus radical 7. Go ahead and try that one on your own. Write down what the conjugate is, multiply it by its conjugate. I'll give you a couple seconds to write the conjugate down. Just keep going. I'll write the conjugate down here in just a second so you can double check to make sure you got the conjugate right before you keep going. Okay, so just, I know some of you are still working, you're working on it obviously, but just look up and double check to make sure you got the conjugate right before you finish off. If you don't have the conjugate right, you're in trouble from the get-go. So. Did you get your car fixed?
This is what I was told. I think. I got sleeping on like $15 to $20 worth of gas.
Ooh. I told you mine died. Did I tell you that? I
Oh, yeah.
3,800.
Anything about it because I'd have to drop my whole rear subframe.
So they
to
wanted,
change my tank.
yeah, the alternator was bad. They had to put a new alternator on. Then something was leaking into something was leaking that was ruined the alternator. And then of course they wanted to just fix everything else. They wanted to put a new timing belt on it. They wanted to do all of this, and I'm like, the car's not. I did the alternator. They did that, and it was like $1,800. But and the other piece that had to be, because there was something that was leaking on it that had to be replaced, it was like $1,900. And he's like, you need a new timing belt, this, and this. And I said, my car is not worth it. It's worth it for me to drive. I said, is the timing belt going to break anytime soon? He goes, I don't think so, but I can't guarantee that. I said, you know what? If it goes, it goes. I'm going to put this money in it to get it running. If it lasts me 3 months, good. I'm good to go. But I don't want to put another $3,000 to put in a new timing belt. So not going to do that.
Mine's
It's not worth $3,000.
$500. I really don't care.
Yeah, that's kind of where I was. So the numerator, we end up with 10 minus 2 radical 7. Distribute. 25 minus 5 radical 7 plus 5 radical 7 minus radical 49. So that's 25 minus 7. 25 minus 7 is 18. Now, you could leave it like that, and I'd be okay with it. But because 2 goes into all of those, technically speaking, you can divide all of the numbers out front by 2. So you could put 5 minus radical 7 over 9. These two, again, are equivalent to each other. I'm okay if you don't simplify it, just so it's there. Okay. So that was rationalizing the denominator by single term. Remember, if it's a single term, just multiply the numerator and the denominator by whatever the radical is. If there's 2 terms, the conjugate. The conjugate, leave the number the same, change the value, change the sign of the radical. Inside of Schoology today, there's practice work today. You only need to go through question number 14. If you get down to question 15, it's something that we didn't do. You could probably do it. 15 and 16 look a lot like this one. So you could probably do it if you're bored and have nothing better to do. It's the same way. You just have to FOIL both in the numerator and the denominator. But you're not responsible for being able to do those type. So you only need to worry about through question number 14. Through question number 14. So quiz will be on everything we've done since Friday. We'll have a review day tomorrow. Make sure you're prepared for the quiz. And then we have a quiz on Friday. Quiz is, I want to say, like 12, 13 questions. It should be fast.